What's up, y'all? What's up, y'all? It's your boy Rookie HVAC Kid. I'm basically gonna show y'all today the parts of the AC unit, a heat pump in particular. Then I'm gonna go to show y'all a straight AC. Yeah, and I'm only doing this video because one, it's a highly requested video, and two, a lot of people or family watch my videos and they like, I'm watching it, but I don't know what I'm looking at. So y'all gonna know what y'all looking at now. I got my boy Elijah with me too. What's up, bro? He riding with me. I'm showing him the ropes. He know a lot already. He be showing me some stuff. So we treat each other like we equal because we are equal. So yeah. So everything with this unit is gonna start here. This is the condensing unit. This is the condensing unit. This right here is your disconnect. So power starts right here. So yeah, it's your disconnect. You got your fuses. I made sure the power is off like I always tell y'all guys. You got line voltage coming in from your breaker. Power going out, going into the unit. That's all this is. All this is power for this. That's all this is. Nothing more, nothing less. It's power. 240 volts. So make sure the power was cut off. Should have did this first. So when you come in here, you got power coming up to this bad boy right here, which is your contactor. This is like a big switch. You can think of it like a switch. The only way this come on is if you have 24 volts. When you guys cut the thermostat on for cool, 24 volts get sent to this contactor and closes it. So power is allowed. When you cut it off, boom, the plunger opens it back up and you have no power right here. So this coil right here, very important. It's actually one of the things when people say their unit is messed up or it's not coming on, a lot of times it's this. Or it's this. Elijah, you know what this is?
Yeah, that's the capacitor.
Yeah, this is a capacitor, guys. This is basically like stored energy, or it is stored energy. And it basically just helps your motors come on, which is your compressor and your condenser fan. This right here is your defrost board, being that this is a heat pump. This basically helps the fan cut off and defrost the coil when it's very cold outside, and this turns into your evaporator, which we're gonna get into in a little bit. This right here, man, is important. This right here is your condenser fan. If you ever come outside and this is humming and you got it in cooler mode, you got a problem. This has to be running in cool mode. This is what basically is rejecting all that heat from inside outside. So all that hot air that's in your house and you come outside and feel hot air over this, this is all the air that's inside coming out. In layman terms, we ain't gonna get too technical because I want people to stick and kind of just get a simple understanding of how this thing works. So you're not gonna get it all, but just kind of understand. So this right here is your compressor. A lot of people say, oh, it might be low on freon. It's low on freon, which make me say, don't it make you mad when they say low on freon? It ain't freon. Yeah, it could be other stuff, bro. But this is what holds your freon. This is what's moving your freon through the system. This is literally the heart of your system. If your compressor bad, you done. It ain't nothing a tech we can do to make magic if this is bad in cool mode. So much stuff in here, man. This is your reversing valve, and a heat pump. You know this is a heat pump because it has this. This baby right here is so important, man, and hard to put in a system. You know what a reversing valve do, Elijah?
Yeah, so it pretty much switches the flow of refrigerant. So with the heat pump, because normally with the condenser, it rejects the heat, but with the reversing valve, when it becomes the winter time, the reversing valve engages, so it switches the flow of refrigerant. So the condenser ends up being inside. So the evaporator coil normally sucks up heat, like in the summertime, but in the wintertime it does the opposite. So it rejects the heat. It pulls whatever heat it can from outside and pushes it to the evaporator, and then the evaporator rejects the heat into the space. So it's the same thing but backwards.
Basically. So Basically what he just said, but I'm gonna sum it up into layman terms. In the winter time, this becomes the evaporator, and inside becomes this. Basically, everything switches, but it cannot switch unless you have this, which is a reversing valve. This is your TXV. Not all systems have TXVs. Some systems have pistons. But just think of this as a metering device, pressure drop. Think of this as the heart of the system. This is what's pumping refrigerant. Think of this as essential. Like, you need this reversing valve. Like, that's important. And a heat pump. Because if you don't have a reversing valve, or if you have a heat pump and your reversing valve is not working, when it's time for heat mode, it's not going to reverse the refrigerant and turn this to the evaporator and your evaporator to the condenser. It's a lot, but just take it for what it is if y'all can. You got your filter dryer right here. That's your filter dryer. All that does is basically filter contaminants in the system. These are your pressure switches. So if this or this, where's the other one? So you got this one. Should be another set in here too. Yeah, right there. So your pressure switches, depending on what it do, you got a high pressure switch and a low pressure switch. Basically all that does is if it's not a lot of freon in here and the pressure is too low, it's going to shut the system off to save the compressor. And if it gets too high, which is usually from this getting clogged and not getting PMs done, it's going to cause it to come on high pressure and the unit is going to shut off. So they basically just safety switches. Anything I miss out? Anything you want to know? Oh, the accumulator. This basically prevents liquid refrigerant from getting into this bad boy. This is not supposed to have no liquid in it, just vapor. Any questions, bro?
No, we covered everything.
Think of it like this. This unit right here is basically what all the heat that's inside the house is what's being rejected out here. So you got to look at this as the rejection of heat. That's all this is. This rejects heat, outside air, to the outside air. And basically, that's coming from the evaporator. We're going to go in there a little bit to show y'all how everything transfers. I'm new to this. I ain't no teacher. I'm just trying to tell y'all something quick. So this is a heat pump. I got to show y'all the evaporator in a little bit. Again, y'all not going to understand everything. I'm gonna do another video explaining the technicalities of everything. Another video. I'm kind of just trying to show y'all how this thing works. So come over here. This is a condensing unit too. However, this isn't a heat pump like I just told y'all about. This is a straight AC. Elijah, what's the number one thing? How do we know that this is a straight AC and not a heat pump like I was just showing over there?
Definitely if it has a reversing valve or not.
So put it in here. It is no reversing valve in here at all. So this is a straight AC system. Got the same components, but this ain't turning into the evaporator and then the inside turning into the condenser. This is strictly for AC, air conditioning. You come over here, you got a little baby filter dryer, filter contaminants. You got your power. You can't say you don't have this. This has to have power coming to it or it's not gonna work. Yeah, power comes to this. This is your switch. It could be a single pole, double pole. This is a single pole contactor. Yeah, your coil that controls and tells this when to go through. The power is on, so we gotta be careful. I didn't even think of that. This is your capacitor. Same concept, man. This is just strictly for AC. Put this back on. So yeah, come over here too. I'm gonna show y'all this too. So when we hook up our pressures and we want to see if it's enough freon in the system, like a lot of people say, take these caps off. They want to act stupid on camera. That's not good that we just heard that. I don't see no traces of oil though. This is your suction. This is your liquid line. Pretty simple. I'm not gonna really get into how these work, but suction, liquid line. This is your filter. The air handler right now. This is what you're gonna find in your house. Filter goes right here. Return air goes over it. Goes over the evaporator. You need to change this so the evaporator is staying clean, free from contaminants, and filtering everything. Everything's right. Take this off. You got that 6? You got that 11-to-1?
Oh no, I think it's outside.
It's outside.
Yeah.
I'm gonna go get it real quick. Alright, y'all. So this is the second compressor. This is the filter. Return air goes over this. Goes up to the evaporator. You need this clean. These are dirty, man. This can mess up a blower motor. Can clog up your evaporator. A lot of things can happen if this filter inside this is not clean. Alright, so right here, y'all, this is the evaporator. This is basically what's inside of your house at the air handler. This is what absorbs heat. All the heat from inside the house is absorbed here through the refrigerant and sent back outside to that condenser that I just showed you guys. This is a TXV. Usually heat pumps have 2 metering devices because, like I said, sometimes this in heat mode will turn into the condenser. Pretty interesting setup. Any questions out here, bro?
No. Everything good?
These are your distributor tubes. They go through the evaporator. Again, this is the TXV. Equalization tube. How did it go? Yep. Yep. So I'm being a little lazy. I might do it. The blower is in here. That's basically just how air moves. If you don't got no air moving, nothing else matters. Airflow is one of the most important things in the AC system. If it's no airflow, you doomed. Should I show them, bro, what it look like?
Yeah, I mean, we can go ahead. Just so they know what it looks like.
Lazy for real. Alright. So yeah, this is your motor. You know what kind of motor this is, Elijah?
It's ECM motor.
Let you show. Yeah, I thought I was gonna trick them up. This is an ECM motor, y'all. So this is an electronically communicated motor. It has a module on the end of it. Basically, with these motors, you're gonna get high voltage at all times to it, but you have a 24-volt tap that goes to the speed from common to whichever tap that you have low voltage for, and that's gonna basically adjust the speeds for you. Did you know that's how it worked?
Yeah. Mm.
Okay. These are expensive motors. Most units have a PSC motor, which has a capacitor in it. Basically the same one like we saw at the condenser. But instead of it's not a dual, it's just usually like a single. So yeah, we even show y'all the color and codes of the thermostat as well too. Mine as well. You know all your color codes?
Yeah.
So yeah, it's a pretty interesting device, y'all. I just kind of want y'all to know what it does, and I don't really want y'all to know the technicality side of it, because y'all ain't go to school for that. frankly, y'all don't probably care, but y'all definitely should know what each part of the system is. Y'all get it. So when a person like me come out to diagnose, or Elijah come out to diagnose, we kind of got an idea what's going on or where it's coming from. So this is the air handler, and outside is your condenser. Alright, so you come closer. This is your drain pan. Well, it's not your drain pan. This is your drain line, drain pump, condensing pump. Right there. And all this does is basically take the water and pump it outside. A lot of times when the person be like their house is leaking water, this is clogged up, and you need to have somebody come out there to unclog this. This right here is your thermostat. Of course, y'all know what this is. This basically controls everything. So, simple unit. This is not a lot of wires. R is your power, 24 volts. C is your common. G is your fan. Y is your cooling. If you had a Y2, that'd be your second stage of cooling. Another compressor. W is heat. This is your second stage of heat. RC, power to cooling. Not sure what K is. S is your sensors. If you was to have like a what is it called? Zone. O is your reversing valve. If you had a root or a ring, B would be used. E, emergency heat, auxiliary heat. Pretty cool. But yeah, this is your straight AC, so it's not all them wires. Alright, y'all, so that's it for this video. So yeah, y'all, what y'all should have learned today, you know, it's a heat pump. We got a reversing valve. This basically is like everything. This from the inside to the outside. You gotta have these two main components for refrigerant to move that heat where you want it to go, and everything works. There's so much, man, I can teach y'all, man, but basically I just wanted y'all kind of get the understanding of what every part was and how it works. Maybe another video I actually get the theory of it so you guys could further understand it, but today I just kind of wanted y'all to understand how everything works. Appreciate y'all for staying tuned. Like, comment, subscribe. Elijah, you got any questions, bro? You ain't got no questions for me, bro?
I ain't gonna lie, not really. I mean, you explained everything pretty good, so
okay. Yeah, man, Elijah been doing pretty good, man. Good work. Yeah, man, we gonna all grow this year. Again, like, comment, subscribe. Y'all stay blessed.